So this next unit is all about chemical bonding, and a chemical bond is the reason why elements can form compounds. So the definition of a chemical bond are forces that hold atoms in a compound together. So to be a little more specific, guys, we call this force an electrostatic force. And the reason why we can do that is because it involves some sort of positive charge being attracted to some sort of negative charge. Now, depending on the type of bond, because there are different types of bonds, what's positive and what's negative might be different. But the bottom line is that you have these oppositely charged things that are attracted to each other that are going to make two things stick together. So that's what a chemical bond is. So why do chemical bonds form? Basically, when atoms combine to make compounds, they become more stable. And what that means is they have a lower potential energy. So the more energy something has, the more unstable it is. And when two things that don't have full valence electron shells come together to make a compound, they kind of calm down and their energy goes down. So they're more stable, so they're less likely to change. So something to help you remember this is the mnemonic device BARF. Okay, and this is going to come up often throughout the year. But to break a bond, we need to absorb energy. So it's hard to break a bond. Bonds don't want to be broken because the atoms are stable and have less energy when they're together. So you have to put in energy to do that. Where if I want to form a bond, energy is going to be released. So the amount of energy is going to go down. And that's why chemical bonds form. So before we get crazy and start drawing compounds, we need to know what Lewis dot diagrams are, and we need to understand the octet rule. So a dot diagram is just basically you taking the symbol of the element and using dots to represent how many valence electrons are in that atom. Okay, so in our periodic tables, in your honors periodic tables, we actually wrote above each column how many valence electrons each of those things have. So if you guys could take that out right now, I want you to find sodium. So sodium is in group 1. How many valence electrons does sodium have? It has 1. So I would put 1 dot on my sodium symbol. Now, what I like to do, I like to start at the top. Now, electrons like to spread out. So they're going to spread out before they start pairing up. So for example, if I jump over to magnesium, magnesium has 2 valence electrons. So I'm going to put 1 here, but then my next one is going to be to the side. Boron has 3. 1, 2, 3. Carbon has 4. 1, 2, 3, 4. So guys, once you're past 4 valence electrons, each side of the symbol has an electron there already. Now my electrons are going to be able to start pairing up, and you want to keep this like order. You want to keep going in the clockwise direction, pairing electrons up. So to make nitrogen have 5 valence electrons, I would do this. 1, 2, 3, 4, 5. Oxygen has 6. 1, 2, 3, 4, 5, 6. Fluorine has 7. 1, 2, 3, 4, 5, 6, 7. And neon has 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now, guys, neon is a noble gas, And our noble gases have 8 valence electrons, which means that they are stable. So because neon doesn't have any openings, it's got 2 electrons on each side of its symbol. It doesn't need to bond with anything else to get a full valence shell. So it already has 8, it's already happy. If you look at every other element that we drew a Lewis dot diagram for, none of them have 8 valence electrons, so none of them are chemically stable. So what they're going to do is they're either going to gain electrons or lose electrons or share electrons, which is these are ways that atoms form chemical bonds. And the purpose of them doing that is to somehow get a valence shell that has 8 electrons in it. So they all want to be like neon or like a noble gas. Okay? All right. So let's look at, we're going to look at ionic bonding first. That's what this video is going to be about. So to know what type of bond you're dealing with, guys, you need to know what kinds of elements are in the compound. So we know that it's going to be an ionic bond if we have a metal and a nonmetal. And if you remember drawing the staircase on our periodic table, the metals are to the left of the staircase, except hydrogen, of course, and the nonmetals are to the right. So if you have something from each side, you know it's an ionic bond. What happens with electrons is that they transfer from the metal to the nonmetal. So again, guys, this is something we've already talked about. We know that metals like to lose electrons and become positive ions to get stable. And we know that nonmetals like to gain them to get stable, and they become negative ions. So these positive and negative ions that are going to be created, they're very attracted to each other. So they're going to stick together and form a very strong ionic bond. And another name for an ionic bond is a salt. So we kind of think like, we always, when we hear the word salt, we assume like NaCl, which is like the salt that you put on your food, that's table salt. But really, any ionic compound we can call salt. It just might not be the salt that we put on our food. Okay, so let's look at how to draw Lewis dot diagrams for an ionic compound. So the first thing we're going to do is we're going to take my metal and my nonmetal, and we're going to draw their Lewis dot diagrams for when they're alone. So sodium has 1 valence electron, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So chlorine already has 7 valence electrons. It only needs 1 more to get stable. So what's going to happen is my sodium is going to transfer its valence electron over to chlorine, and that's going to make chlorine have a valence shell of 8, which is good for chlorine. Now you might be thinking like, how does that leave sodium stable? If we look at the electron configuration for sodium, when we lose that valence electron, our new valence shell is the second shell, and it's filled with 8. Okay, so Na and Cl, when they get together, they're a perfect match. So now how do we draw our compound? Right now I just showed my work. Now I need to draw my compound. When we draw ions, we draw them in brackets. So sodium had 1 dot, then it gave it away. So sodium has no dots, brackets, and because it lost an electron, now it has a positive 1 charge. It's a +1 ion. Chlorine is now an ion. It had 7 electrons, now it's got 8. And because it gained 1 electron, it has a -1 charge. So this is my final answer. This is sodium chloride. My positive ion and my negative ion stick together. All right? It gets a little bit more complicated. Let's look at this one together. So calcium has 2 valence electrons, and chlorine has 7. So what's going to happen here? Same thing as before. Calcium is going to give its valence electron to chlorine. Chlorine is going to be all filled up with 8. So now, can this calcium be left with one valence electron? Absolutely not, because if it has one valence electron, it's very unstable. It wants to have 8. So guys, if your metal has 2 valence electrons or 3 valence electrons, it has to give all of them away. It can't just give away one. So for this example, I need another chlorine because I need to give away another electron. Now that I have a second chlorine, I have somewhere for that other electron to go. So right now you might seem like, how are you allowed to do that? So I want you guys to just think of like water. Water is like the most common compound that everybody knows. Everyone knows how to make water. How do you make water? You put together 2 H's and 1 O. So not every compound, not every atom in every compound fits together in a 1-to-1 ratio. To make water, I need to put together 2 hydrogens and 1 oxygen. And it's the same thing here. I need to put together 2 chlorines and 1 calcium to make this compound. They didn't fit together 1 and 1 because calcium needed to give away 2 electrons, and chlorine only had a spot for 1. So it's kind of like a puzzle. You have to figure out how many of each you need to put them all together. Okay, so what is my final answer going to look like? My calcium is going to be left with no dots. It's going to have brackets. And because it lost 2 electrons, we're going to give it a +2 charge. Okay, now my chlorines, guys, I'm going to draw one chlorine first. It had 7, now it has 8. It gained 1 electron, so -1 charge. It's very important that the other chlorine you put over here. So it's the positive and negative attractions that are holding this compound together. You don't want to put 2 negative things next to each other. Or if it had 2 positive things, you wouldn't want to put them next to each other. Okay? Now, I want to show you guys, a trick, which you're actually allowed to do. Aside from drawing a Lewis dot diagram to figure out that this compound would be CaCl2, where this compound was just NaCl, that was its formula, there's also a little shortcut. If you take the metal and the nonmetal and you write their charges, on our periodic tables, we wrote down what type of ion each column creates. So before drawing dot diagrams, we knew calcium can become a +2 ion and chlorine a -1. If you take those ion charges and you crisscross them and bring them down, you're going to get a 2 next to the chlorine and a 1 next to the calcium. That tells me I'm going to need 1 calcium and 2 chlorines for them to fit together. All right, let's try it with this one. I have sodium and oxygen. If you look up the charges, you have a +1 and a -2. What happens when you crisscross? You need 2 sodiums and 1 oxygen. So let's check to see if that's right. Sodium has 1, oxygen has 1, 2, 3, 4, 5, 6. What's going to happen? Sodium's going to give to oxygen. Sodium's good. Is oxygen good? No, because now it only has 7 electrons. It needs 1 more sodium to get 8. So I needed 2 sodiums to fill up oxygen. And doing this little crisscross thingy here, that was my way of knowing that beforehand. So what would my dot diagram look like? Oxygen now has 8 valence electrons. It gained 2, so it has a -2 charge. Each sodium lost its valence electron, so they're left with no dots and a +1. Okay, so guys, this next one is a challenge, and what I want you to do is try it on your own. And this is going to be something that we look at tomorrow in person. All right. Thank you very much, and I'll see you later.